guys, so we have given one question here which is based on the electrical networks. So basically this is the part of the syllabus of the 10th class CBSE and ICSE board and even the state board. This is the one important, and also it is the part of the 12th class syllabus of state board and the CBSE board, okay, and ICSE boards also. So we'll see here in this question how to solve such questions if they will be asked in our exams and all. Okay, so in this question, what is asked to us in this question? Find the current through the 2 ohm resistance. So already the solution is given here, so it will be easier for us to understand how it is solved here. So we can see here is that one circuit is given in the three resistors are connected together to the 9-volt battery. Now you can see that this is the combination of the resistors in a series and parallel way. So first of all, we can see what is given to us. That is, first I have taken the R1 as a 2 ohm, R2 as a 4 ohm, R3 as a 18 ohm, and the total voltage is 9 volt. Okay, now what do we have to find here? We have to find out the current that is flowing through the 2 ohm resistance. So you can see here in this diagram, I have taken the total complete current, that is I, and it is going to get bifurcated at the junction as I1 and I2. Now I2 is flowing through the 18 ohm resistance and I1 is flowing through the 2 ohm and the 4 ohm resistance. From the figure we will going to get the idea that R1 and R2 are in series. Okay, so if they are in series, what we will do, we will just add them in such a way, so we'll get the series resistance that is equal to R1 plus R2 equal to 2 plus 4 equal to 6 ohm. Okay, fine. So we got one series resistance here. Now we will come across the another combination. Now this 2 and 4 ohm will become the 6 ohm, that is RS is given here. Now this total series resistance and the 18 ohm resistance will be in parallel to each other. Now we will solve this particular small circuit or that is a loop. Okay, so now in this loop RS, it is not R5, it is RS and R3, they are in parallel. So we will apply the formula for the parallel combination of the resistors, that is equal to 1 upon RP equal to 1 upon Rs plus 1 upon R3. Okay, now we know that the series resistance was 6, so it is 1 upon 6 ohm, and the parallel resistance was 1 upon and third resistance was 1 upon 18. So 1 by 6 plus 1 upon 18 is equal to, now I have taken the LCM, so LCM will be the 18, so it is equal to 3 plus 1 divided by 18. Okay, you can solve this particular simple relation that is given there. Okay, addition of the rational numbers, so we know how to solve it. Yes, if you don't know, so there are 2 or 3 methods. So basic method is cross multiplication, another is a LCM method. So I have taken here the LCM method. Now from this solution we will get 1 upon RP is equal to 4 by 18. So we want RP, so I will take the reciprocal of the 4 by 18, that is 18 by 4, that can also be taken as a 9 by 2 ohm. Okay, now what is this 9 by 2 ohm? 9 by 2 ohm is the equivalent resistance of this whole circuit, and because of that, whatever the total resistance offered by this electrical network or the circuit will be 9 by 2 ohm, or we can simply write it as 4.5 ohm. Okay, now we will go further. Okay, now you can see here, after getting the total resistance, I can calculate the total current by using the Ohm's law, that is I is equal to V by R. Okay, so if I is equal to V by R is there, it means that I will use this formula V by R. So I have taken here. Now total voltage is 9 ohm and total resistance that we got here is 9 by 2 ohm, that was also 4.5 ohm. So just I will divide 9 by 9 by 2. Okay, I will get the answer, that is 2 ampere. So we can see that this 2 ampere is the total current or the equivalent current that is flowing through the complete circuit. Now at one junction you can see in the figure, okay, that I is bifurcated into I1 and I2. You can see again such a relation is I1 is there and another is I2. Okay, so now we know that I2 is the current flowing through the 18 ohm resistance, and across it we have the supply of the 9 volt voltage. So we can calculate the current flowing through the 18 ohm resistance, that is I2. Now what is the potential difference for this? That is the 9 volt and this is the ohm, that is the 18 ohm is the current. So because of that, by using again the Ohm's law, we can calculate the current that is flowing through the 18 ohm resistance, that is 0.5. But this is not our target. Our target is we have to find out the current that is flowing through the 2 ohm resistor which is connected on the upper side. So what is the current flowing through the 2 ohm resistance? That is I1. You can see here. Okay, so here it is I1 is flowing through the 2 ohm resistance. So we can say that I1 is equal to I minus I2, because I is I plus I2. Okay, from diagram, so you can see the diagram again. So here we will get the idea that for getting the I1, I will just minus the I2 from I1, complete I. So 2 minus 0.5 will be 1.5 ampere. So in this way we can calculate. Now what is this? This is the current flowing through the 2 ohm resistance. So in this way, by simply applying the three formulas, we can get the current that is flowing through this 2 ohm resistance. So what we have done here? Okay, so we have just calculated first. So what was our first step? We have calculated the series resistance from 2 and 4 ohm. Then we have calculated the equivalent parallel resistance for this circuit. Then after that we have calculated the complete current, and finally we got the current that is flowing through the 2 ohm resistance. Okay, so in this way we can calculate any type of a question which are based on the electrical circuit or electrical networks by using the simple Ohm's law and formula of the series and parallel combination of the resistors. I hope this is got to you, and I can hope that this is easier for you for to calculate the further answers and all. Okay.